about the triangle inequality. The triangle inequality is one of the most important, if not the most important inequality in all of math. And it comes up in lots of different places. So we're going to write the triangle inequality theorem. Inequality just is like greater than or less than.
Oh, okay.
So the triangle inequality theorem says that the sum of any two sides of a triangle is greater than the third side. And kind of in everyday language it says if we add two sides, they have to add up to bigger than the third side. So for any triangle, if we add any of the two sides, the number that we get has to be bigger than the third side. If this is not true, we don't have a triangle. And in pictures, if I draw, I'll draw a triangle and I'll put the sides in different colors. So here's one side, here's the other side, and here's the third side. If I add up any of the two sides, and the red and the blue, that number has to be bigger than the green side. If I add up the green and the blue, it has to be bigger than the red. And if I add up the red and green, it has to be bigger than the blue. If this isn't true, what we end up with is, if I have this side here, and I'll just do one of them, if the red and the green are not bigger than the blue, I end up with something like this. For my segments, and these aren't long enough to connect to the end of this one. So if I try to make a triangle, they're going to connect somewhere over here rather than at the end. So the two sides have to be, when I add them up, they have to be longer than the third side in order to have enough room for them to go up and make a triangle. Is really all, this is what the triangle inequality is telling you. So in order to have a triangle, the two sides, any of the two sides, we have to add them up to be longer than the third side. Any questions on what the triangle inequality is telling us? All right, let's look at a couple of problems. Use the way the problems might be given to you using the triangle inequality. So we'll do three different problems. Can we make a triangle with these three sides? So for the first example, we have 14, 8, and 25. So we want to know if these could be the side lengths of a triangle. So I'm going to add up 14 plus 8 is 22. 22 is less than 25. So that those two sides aren't long enough to connect up and make a triangle with the third side. So my answer would be no. We can't make a triangle out of those sides. So any pair of the two, if we add up any pair and it's smaller than the third side, no matter which one, then we can't make a triangle. So let's look at another combination. 7, 23, and 16. We want to know if we can make a triangle out of these three sides. So 7 plus 23 is 30. 30 is bigger than 16. So those two sides are okay. 23 plus 16 is going to be 39. Well, that's way bigger than 7, so those two sides are okay. 7 plus 16. 7 plus 16 is 23. That equals 23. It's not bigger than 23, it equals 23. So we still can't make a triangle. My three sides would be like the picture that I drew. It'd have this one, and they'd be, when I put them together, they're exactly the same length as the third side. So my triangle would be flat. So this is a no. I can't make a triangle out of those three sides. The two sides have to add up to be bigger than the third side. Let's look at another combination. 8.
What's the biggest number? Are you assuming about the base?
It doesn't really matter how it's arranged, but when I add any two of the sides, that number has to be bigger than the side that we didn't add. So any combination of two, it has to be bigger than the one that we didn't use. Okay? So no matter how we arrange them, the two have to add up to be bigger than the third. Yeah, then. Okay. And if you're doing these problems, as soon as you get to one that doesn't work, then you're done. If one doesn't work, then that means you can't have a triangle. So let's look at these three sides. 18 plus 8 is 36. That's bigger than 24. So those two sides are okay. 8 plus 24 is 32. And that's bigger than 18. 18 plus 24 is going to be way bigger than 8. 18 plus 24 is 42. And that's bigger than 8. So all three combinations work. So this is going to be a yes. So we just add the two, add two sides. If that number comes out to be bigger than the third side, the side that we didn't use to add, then it works, and we check for all the possibilities. Questions on triangle inequality? All right, I want to look at a couple of the problems from that worksheet, the 4.8 homework. So down at the bottom, number 4, we'll look at a couple of those from the bottom. So number 4 says we want to determine the largest and smallest possible values for x if we have these three sides of our triangle. So number 4 says AB equals 7, BC equals x, and AC equals 11. So what we're looking at, just a quick sketch, we have triangle ABC. This side is 7, this side is x, and this side is 11. So it wants to know what how long can side BC be in order to make a triangle with these other two sides? So we're going to use a triangle inequality. We're going to write inequalities here. So I know that 7, I'm going to use these two sides first. 7 plus x, when I add these two sides, that has to be greater than 11. Those two sides have to add up to be bigger than that side. And I'm just going to solve this inequality for x. So I subtract 7, and I get x is greater than 4. So when I use these two sides, that tells me that x has to be greater than 4. Now I'll use these two sides. 7 plus 11 has to be greater than x. 7 plus 11 is 18. 18 is greater than x. And if I use the other two sides, if I say x plus 11, I just want to show you if you do these problems and it turns out this way. If I write x plus 11 is greater than 7, and I subtract 11, I get x is greater than negative 4. Well, I can't have a negative side length, so I'm just not going to worry about this. If you get something negative, if you get something like this, just don't worry about that inequality. So I'm going to cross that one out because we can never have a negative side length. Yes?
So, are we trying to find an x?
Yes.
So, x would be greater than 4 and
Less than 18. This says 18 is greater than x. So if I turn this around, this says 4 is less than x, and this one says, if I just flip the order, x is less than 18. So the way it's written on your homework, we have an x and we have our inequality arrows here. The 4 goes on this side, and the 18 goes on that side. So 4 is less than x, and x is less than 18. So x has to be between 4 and 18 in order for these side lengths to make a triangle. So this would be our answer. So let's look at number 5. Number 5 is the same kind of problem. So we have our 3 side lengths for our triangle. It says DE is 2x, DF equals 3, and EF equals 5. So you don't have to make a sketch. It might help you think about what you're doing. This is triangle DEF. So DE is 2x, DF is 3, and EF is 5. So we have a triangle that's set up like this, and we want to figure out what value of x would let us make a triangle with these sides. We're going to use a triangle inequality. So I'm going to say that 2x, I'm going to use these two sides first. 2x plus 3 has to be greater than 5. I'm going to solve that inequality. 2x is greater than 2. Divide by 2. And x is greater than 1. I can turn this around. I can just change the order and say 1 is less than x. Those two things mean the same thing. If x is bigger than 1, then 1 has to be less than x. So that's for these two sides. Let's use these two sides. 2x plus 5 has to be greater than 3. I subtract 5, and I get 2x is greater than negative 2. Divide by 2, and x is greater than negative 1. Well, I can never have a negative side length, so I'm not going to worry about that one. So let's use the last combination. 3 plus 5 has to be greater than 2x. 3 plus 5 is 8. That's greater than 2x. Divide by 2. And this tells me that 4 is greater than x. If I turn this one around, I get x has to be less than 4. 4 is greater than x is the same as x is less than 4. So my inequality, if I fill in my answer, I would have 1 is less than x is less than 4. So x has to be between 1 and 4 in order for this triangle to work out. Problems 6 and 7 are exactly, you work them out exactly the same way. Just solve the inequalities for x and figure out what x has to be between in order for that triangle to work. Questions on triangle inequality?